Good afternoon. Annyeonghaseyo. It is my first time to Korea. I'm from Australia in Sydney, and I live in Singapore. My name is Benjamin Henshall, and I am the Director of our Application Development Solutions in Asia Pacific. Let me start with a short story. I'm sure many of you have had the same experience as my neighbour did. This happened the other week. He was on a British Airways flight, sitting on the tarmac at Changi Singapore International Airport, ready for departure to Sydney, Australia for some work, when over the PA, the captain announced that there was an issue with the navigation system and that they were to wait on the tarmac for an hour while they fixed the navigation system. The captain said, "Sit back, relax, and we'll give you further updates." Now, my neighbour was quite sceptical. Something wrong with the navigation system in an aeroplane, and an aeroplane needs navigation. That it would be fixed in an hour. An hour passed, and he was told that they all had to disembark the plane and go back to the Changi airport lounges and enjoy the surroundings there for several hours while they fixed the plane. Well, needless to say, they didn't fix the plane, and he went home at 2 o'clock in the morning because they didn't have a plane. He subsequently got on the plane to Sydney, Australia 15 hours later. He was slightly annoyed. Has that ever happened to you? Planes, trains, and automobiles. The reliance we have on them and the inconveniences we experience when things break down. Moreover, the level of expectations you and I have about how things ought to work. You know, we humans are very impatient because we're always fighting the clock. Time is our most precious asset, and once we give it out, you can never get it back. So what's this got to do with my talk today with IoT? Well, the airline industry knows delays happen all the time due to various issues. And many times the cause of the delay is not having the right information about the aeroplane and its thousands of interconnected components. By the time the fault is identified, it needs parts, it needs subject matter experts, it needs engineers, and it needs analysis, and on it goes. So manufacturers of plane parts are building components that record and send information about themselves and notify ground staff real time when a problem arises, so that when the plane lands at its destination, with engineers, parts ready, they're ready to fix the issue, dramatically lessening the amount of unplanned downtime and saving millions of dollars in expenses and improving productivity. So let me just start. I think it's helpful to define what is the Internet of Things, particularly given the explosive interest and, more importantly, the types of business models that are coming out of this new architecture. The term Internet of Things has been around for over a decade, first being proposed by a gentleman called Kevin Ashton from the research centre at MIT in Massachusetts called Auto ID. It was primarily driven out of the RFID concept, the radio frequency identification idea. You know, the ability to track and dumb terminals or devices and machines through a wireless system. But for a number of reasons, the ideas and use cases for the Internet of Everything, as it's called, has taken a while to mature. The drivers behind IoT have been several, and the ones that I'm about to list are in no way exhaustive. Let's just talk about utilities for a moment, shall we? The demand for renewable energy means that smart grids have got to be able to monitor and respond to demand in electricity generation in a much more agile manner. You've probably heard of smart meters, yes? Where your power box is attached to your home is sending and receiving data about its usage. And with people's homes now, they are actually not just consuming energy, they're actually producing it. And they're able to resell that excess energy back onto the grid real time. Let's just talk about the mobile workforce and customer engagement. There's that exponential growth of smartphones. More people are always connected, and that trend will continue to rise for personal consumption, but more so for workforce productivity. Cisco estimates the usage of devices to grow to about 50 billion internet-connected devices in the next 5 years. IDC actually brings that to 212 billion connected devices, and Gartner predicts it'll be worth about $300 billion, and that's just within 5 years. Let's just talk quickly about logistics and transportation. With the need to monitor and track the locations, temperatures, speed, and potential hazards ahead to ensure deliveries occur on time and issues are resolved. The internet has become a medium to connect people, share information, find solutions, and report problems. With the advancement and availability of smart devices, the internet is evolving to the internet of everything. Billions of interconnected devices and machines measuring, collecting, analysing, monitoring, and sharing useful information. So IoT, or the industrialised internet, is best thought of as the devices being the ears and eyes, capturing and sending back data and receiving updates and notifications. But these devices are not the brain. Your smartphone in your hand gets those pesky notifications sporadically telling you of a new update to a game, or someone on LinkedIn wants to connect with you. There is a brain behind the scenes sending that notification to your phone. What is critical to appreciate with IoT is the objectives for monitoring these end devices. And here is the very important point. It's the business models that are to come. If you can monitor and track and collect data, not information, because it's not information, it's just data, about a device in real time or much more frequently, then this opens up many possibilities of innovative business ideas. To come back to the original story of my friend's horrible flight, GE are collecting terabytes of information about their engines on flights. With that new data now detached from the physical device, this opens up the possibility of selling their engines to Boeing and Airbus as a service, rather than just a physical engine. They could start charging airlines by 1,000 different metrics and really disrupt the engine manufacturing business model. It's quite breathtaking. So we have devices on one side, data in the middle, and the business on the other end. What we also need to take into consideration is that IoT still falls largely within enterprise IT department's responsibility. It's not something separate from enterprise IT. And as such, when applying IoT solutions, it's more than ever a requirement to apply the existing fundamentals of enterprise IT to them. The first is reliability. Make sure the overall IoT system is up and running. When something goes down and information is not sent, what happens? The second is application and device lifecycle management. One question you have to ask yourself with thousands and thousands of connected end devices: how are you going to patch them simply? How are you going to do DevOps with an IoT application architecture? Start doing rolling deployments, continuous delivery on thousands of devices without affecting downtime. How are you going to do auto-scaling and rollbacks? The third is security, because we all know the internet is incredibly secure, don't we? It's free of malware, free of hackers, free of security threats. What could possibly go wrong with data coming in and out of devices? So we need to apply the same security principles to IoT and having a secure network, lockdown operating systems, etc. So we've discussed briefly IoT, what IoT is, and the few trends, and the relationship with business. But really, what does an IoT structure or architecture look like? Well, I'd like to propose Red Hat's point of view on this. The devices and endpoints on your right, they are the dumb terminals and devices that have limited functionality, but you can both either send or receive data. And these devices generally need a very agile, lightweight way to send and receive messages, usually in a variety of protocols and formats, and in many cases securely and encrypted. In the middle is the mediation point known as the gateway, the middleman, so to speak, where data is received by the end devices, and before sending it back to the central data center, data is usually captured, it's possibly stored and analysed, and either the results from that analysis are sent back to the data center you see on your left, or an event or action is triggered back to the device. The middleman also does a very important job of reducing the amount of traffic load on the network, and it's closer to the edge devices. You see, not all data needs to go back to the central data center, and more so the data coming from the devices can be acted upon closer to it rather than going all the way back to the head office. This is particularly useful when sub-second response times are required. And thirdly, just as mentioned on your left, is the brain of the IoT, the data center or cloud holding all the data received. This central data center acts as the deep analytics center where trends, decision rules, complex correlations are modified and then adjusted to the gateway systems or edge devices. So in light of that, how does Red Hat's components fit into this three-tier sort of model? Well, right off the bat, I'd like to state that Red Hat does not have an IoT solution. We don't have an IoT product. It's an architecture. It's not a single product, but it's an architecture and an approach to solving connection and integration problems which help drive, and this is very important, new business models. That is, Red Hat provides a comprehensive portfolio to deliver innovative IoT capabilities. So starting from the bottom, we have a mobile solution, Red Hat Mobile Application Platform, which spans all three tiers. This is about development for devices, tablets, wearables. And then we have the world's leading and most secure Linux distribution in Red Hat Enterprise Linux, and all its variants like our container-based atomic host. Just think, as devices become more and more pervasive, what is the one thing that they're going to need to be able to do to send and receive messages? It's an operating system, and a highly secure, standards-based, easily updatable one at that, and Red Hat fits that to a T. Then above Red Hat Linux, we have a broad and comprehensive middleware portfolio covering functions like extreme scalability, lightweight, reliable messaging, mediation, data grids, integration, business rules, etc. Then above the middleware, we have software-defined storage with Ceph and Gluster are our open source projects, being a highly scale-out capability to handle huge quantities of temporal or permanent data, but on commodity hardware. If you just think about the type of scaling you're going to need for this data collection that you've got, why use a proprietary scale-up infrastructure when you can use a scale-out software-defined infrastructure? Then above that, we have Satellite as the systems management and updating tool to update servers and end devices, applications, and ensure each system is compliant and up to date. And then finally, at the data center, the IoT architecture needs a highly scalable, cloud-like infrastructure as a service and platform as a service layer to handle the breadth of applications, analysis, and data capturing. When you think of a tool like Red Hat OpenShift, which uses developer-friendly Docker Linux format, it makes the development, testing, and of critical importance, the deployment of application code, be it on the edge devices, or the gateways, or in the data center, very, very standardized and automated. This is so critical with IoT. The elegance of Red Hat is that our technologies are designed to be deployed on-premise, or in the public cloud, or both, so that you can decide which parts of your IoT system run best according to the business and technical constraints and resources that you have. Taking a functional angle of IoT, one can see that the data center, the brain at the top, performing complex core tasks to address the influx of information and data from the gateways and devices, requires multiple software development tools like business rules event processing, data analysis, enterprise integration, and so on. A simple example, when data is received into the data center and it triggers an event to process it, based on either a temporal correlation of events, and one is loading that data into, say, a Hadoop cluster, how are you going to be able to rapidly scale your infrastructure compute for that data? It's called Red Hat OpenStack. And more to the point, are you going to pay expensive storage hardware to store all that data that needs some crunching? Why not use commodity hardware and software-based storage like Red Hat's. As you move down the gateway level, the key here is that not all data needs to go back to the data center for processing and storing. Just think about the load on your network and IT infrastructure resources if you were to do that. Rather, the gateways act as the middleman, doing some of the heavy lifting on behalf of the data center. This is where you want a cost-effective software application layer to integrate, decipher, and determine data rapidly and make decisions on behalf of the data center, and only send back important information once it's been analysed by that middleman. This is where tools like complex event processing engines and business rules that are part of the JBoss Business Rules Management platform come to bear. Furthermore, as messages, payloads, and data need to be enriched, transformed into new formats, and redirected, JBoss Fuse handles this and does it at web scale. Now, I'd like to draw your attention to security and the lifecycle management because this really is very, very important. It's one of those areas that is rising to the surface as IoT gains the attention of more businesses looking to create new models out of this architecture. No longer on the fringe, where security was a second thought, once it reaches enterprise IT, the questions about how secure is the architecture from the data center to the device and back, and secondly, how on the good Lord's green earth can the software be easily patched, updated, and audited and secured when software fixes and security fixes come in? This is Red Hat's bread and butter, and it's what's made our products used by the most paranoid and secure conscious sectors in the industry and the world today. Let me tell you, if the defence departments are using Red Hat in their defence systems on submarines and frigates and ships to avoid oncoming missiles, then it's safe to say reliability, security, and patching are prerequisites. You might not know this, but the secret sauce to the security of Red Hat Enterprise Linux was born from the joint collaboration between Red Hat and the NSA in America back in the early 2000s. You know, the NSA had developed highly secure policy settings on the Linux kernel to protect the surface attack area within the operating system hosting applications. And they saw the value and potential for contributing it upstream to the Linux community. Secure Enhanced Linux, or SE Linux, was born, and Red Hat has been at the forefront making the most secure Linux distribution today, working upstream in the Linux community. Also notable is that we are applying that same rigor to Docker containers. Furthermore, given that 98% of security vulnerabilities are fixed within one day, given that Red Hat has a 24/7 follow-the-sun support and engineering division with a 1-hour SLA, given these things, we think Red Hat's got you covered. Now that you're about to embark upon an IoT-based project, presuming you're going ahead, the question has to be asked, how can you design, develop, and deploy, deployment being critical, a distributed software solution without breaking the bank and needing a task of 1,000 people to install and manage this thing? And this is where Linux containers comes into play. Linux containers have been around for many years, but in recent times they have literally gained staggering prominence because developers have found their new accelerated development and deployment packaging format, and it's called Docker. Docker is a developer-friendly Linux image format that Red Hat was the first to embrace and support through our distribution of our various products, including RHEL, OpenStack, OpenShift, and our middleware. In short, containers make the developer's life very productive and the deployment process consistent, irrespective of the programming language used, dependencies on third-party libraries or the target host, be it a device, a terminal, or physical or virtual server, or in the cloud. The flexibility and agility this gives to IoT is not to be underestimated. This is what we see on the screen, a Hello World application on 4 different languages, being packaged and deployed in the same Docker format for deployment onto the same Red Hat Enterprise Linux host. But containers also introduce lots of day 2 issues. Just quickly, would I be able to get some water, please? However, Red Hat crucially makes these containers secure, safe, and reliable with a collection of tools like OpenShift and CloudForms. The point about developing software solutions for IoT is that today's development models like waterfall and using existing VM-based approach just are not going to support IoT. Instead, you need a rapid deployment mechanism, and Docker enables that. Linux containers like Docker accelerate the development model, and Red Hat makes them a first-class citizen. Excuse me, thank you. Thank you very much. So I'd now like to move on to the topic of the intelligent gateway, the middleman. The reason being is that you do not have to have a middleman in IoT. You can have the edge devices talk directly to the data center. But there is a significant commercial, business and technical benefit for having a middleman. To start with, think thousands of devices talking back to one single data center. Think of the load and what could possibly go wrong. Latency issues, the network is down, your 3 or 4G network is very flaky. Sounds like a potential nightmare, does it not? And how much extra compute and networking resources would you need at your data center? And this is where the intelligent gateway comes to play. The gateway can execute and resolve certain bottlenecks in the flow of data. The gateway tier can relieve the data center by pre-processing that data, aggregating it and summarizing it, and relaying that and controlling devices according to business rules. It plays a crucial role in data security as well, when it serves to encrypt and decrypt data, since the gateway systems are typically located in the field and proximity to the devices. They also assist in resolving latency issues by cutting the round-trip distance between the data would otherwise have to travel. Moreover, when decisions and actions are needed in sub-second response times, for example, a shopper walking through a mall needing a real-time offer, or a rail transponder needing a decision as the train approaches, having the intelligent gateway near the device is crucial. So here I'd like to spend the next few sections going into Red Hat's capabilities between the device and the intelligent gateway. The first is our messaging platform, JBoss AMQ. JBoss AMQ is an effective messaging system that enables the intelligent gateway to receive millions of messages or data through supporting the well-known and trusted messaging standards that are widely used in IoT. They are specifically AMQP as a standard, MQTT, and STOMP. JBoss AMQ provides the critical function of sending and receiving messages from the devices, the intelligent gateway, and the data center. Within IoT, there is a requirement to support multiple protocols, multiple messaging standards, in multiple communication methods with complex payloads, and JBoss AMQ handles that. This is especially useful when the network goes down. It can bank up these messages and then redeliver them when the network has been re-established. If I can offer my personal point of view here, this is really where enterprise architects and middleware managers are trying to get to with their integration. Integration as a service or messaging as a service. JBoss AMQ, when deployed on a tool like OpenShift using Docker, really supports that and enables an Internet of Things architecture. The second area is for the intelligent gateway or the data center. Now, once you have a messaging layer in place that can send and capture data, it will need to be mediated, enriched, reliably sent on to other applications to do something with. It sounds like a function of an enterprise service bus or a broker, does it not? Well, it's called JBoss Fuse. JBoss Fuse is a Java-based integration framework based on the widely adopted enterprise application integration patterns under a project called CAML. If you are not familiar with Camel, the best way to think about it is it's what Spring did for Java, Camel does for integration software development. And because it's Java-based, it's a natural and productive framework for doing complex integration in a standard, repeatable, secure, and transparent way. Given the wide array of data, the rules and routing when needed, when it arrives, and likely enrichment, JBoss Views protects the need to send data all the way back to the data center, but also enhances the intelligent gateway by making decisions about where information needs to go. JBoss is designed to be deployed in a distributed architecture, which is important for IoT. Secondly, once the data is received and enriched, it will also be sent to a database or a data mart or a data warehouse so that it can be analysed. And this will happen at the intelligent gateway or at the data centre. This is a significant double-edged sword issue for IoT because of the dramatic rise in volumes of data to be analysed. The opportunities for data scientists, business analysts, and IT are both fantastic, but really quite problematic. The main problem being is how do you make accessibility of these data sources to the business seamless and frictionless so they can do their reporting and analysis? Because IoT is all about capturing that data and making smart decisions and automating those decisions. And this is where JBoss Data Virtualization provides an elegant mechanism to virtualize, compose, and connect this data, either going into the target data stores, but more importantly, being used to analyze the data as a virtual database for analysts to do their work. You know the traditional model of copying and pasting and extracting data from multiple sources and then sticking it into another target, and then the analysts do their reporting on. Well, instead of moving that data around, JBoss Data Virtualization can do this in a virtual data mart, abstracting the physical movement of data and presenting it as a virtual database or data table to your business analyst. It's quite elegant. Let me just talk very briefly about the need for sub-second in-field decisions, because IoT enables much smarter decisions and suggestions real-time for field workers or devices than ever before. But it needs a decision engine scalable and responsive enough to capture the data, run it through the decision engine, and then send back an action. And it's called JBoss Business Rules Management Platform that can either run on a device, in the intelligent gateway, or at the data center. It's that flexible. The power of this software is that it can correlate, and correlate is the important word, multiple data points and make a decision that relates them together either over a temporal window or until a threshold of events has occurred. Let me give you an example. A medical device may be monitoring the health of a critical patient. It sends data back every hour that is abnormal, just a small bit of data and a small abnormality. It then sends data that shows a doctor hasn't visited them for over 120 minutes. Now, independently, those data points are unrelated, but together they mean something. The patient is needing attention. JBoss Complex Event Processing Engine within the Business Rules Management System does that correlation for you and then can trigger an alert or an action or sound an alarm. And finally, a simple overarching look at what the high-level functions of an IoT data center look like. This is the brains. The simple messaging being that if using a 3-tier architecture as previously described, or even a 2-tier architecture, the business value of IoT is in deciding how best to analyze and interrogate the data so the business can tweak and optimize the decisions and actions from it. Tweaking and optimizing are critical. As you see, Red Hat has tools to support the ingesting and crunching of that data and scaling it for capturing and analysis through Splunk, Storm, Spark, or Hadoop, etc. And this is where Red Hat OpenStack and our software-defined storage are so well placed. Then the need to make that data discoverable and accessible for the business through bespoke software applications, caching the data, implementing rules and decision services and the like. So as you can see, the four key players of ingest, integrate, discover and analyze, and then act, all combined to make IoT useful and powerful for smarter and more accurate real-time decisions about and Red Hat has a comprehensive portfolio to address this. Just very quickly, let me just talk about an example, of which we have many, but I think this is the most interesting one. This is a story of the US government introducing a policy called PTC. It's called Positive Train Control, which requires that every train, freight and commuter, to be monitored real-time and controllers on the network to notify the locations and speed. The reason for the law was that there was a driver who was texting on his phone. He missed a signal on the track and had an accident that killed people. Given the diversity of trains and rail systems, poor network connectivity, the need to have 5 nines, that is only 5.5 minutes per year of downtime, messaging, real-time responses, and control of the train to stop it, if required, meant a truly industrial IoT software architecture was needed, and Red Hat was that solution. Just think about that, the need to stop a train if it breaks one of the signals. Furthermore, with the IoT system in place using Red Hat, the maintenance of the trains has improved and clearly made life much safer for those living near the railway lines. To give you some perspective on the size of this industry, the solution by Red Hat in conjunction with a company called Meteoricom handles over tens of thousands of trains and equipment. It covers 140,000 miles of network. Did you know that 17% of all revenue from freight trains is spent on maintenance? If you could reduce that by even 2 or 3%, you're saving a lot of money. One of the oil and gas producers in America using the rail network is shipping over 600,000 barrels of oil a day. That is enough to power 1.35 million cars. It's significant. So as I wrap up, I also want to draw your attention to the broader ecosystem of IoT technology solution providers. Plain speaking, Red Hat doesn't have a product of IoT, but what Red Hat recognizes is that we have a comprehensive set of tools that facilitate and enable IoT solutions. So we are working very closely and investing a lot of money into supporting and partnering with hardware manufacturers, chip devices. We're working with ISVs, and we're working with data management and analytics companies to build out industry-specific IoT solutions. We recognize that the ecosystem is incredibly important in this growth industry. So I hope today that you've seen that the business models based on IoT architectures are already here and they're using Red Hat software, and that the areas are broad and really very, very exciting. The type of business models and ways to improve customer experience, reduce cost, and enhance workforce productivity are very, very interesting. Really, it's about trying to make our lives better. But Red Hat sees this as a huge and continued investment and opportunity for the open source community and partners and customers alike. If you are more technically minded, I've put up some links there and some information you can go and search. I would suggest that Red Hat Insights is an interesting place to start. I really appreciate your time, and I hope the rest of the forum has been useful for you. Thank you so much.